Hey guys, let's jump into a little math. We're going to be looking at chapter 7. On page 383, there's an introduction to chapter 7. We're going to be adding and subtracting fractions. And just to help you with that, that introduction, those 2 pages in the introduction, here are a couple terms that they're going to ask you to learn for this chapter. One is simplest form. And when we put fractions in simplest form, both the numerator and the denominator are reduced down to the lowest common factor. So for example, 1 over 3, that couldn't be reduced any farther, right? It's in simplest form. 2 over 7, that could not be reduced any further. That is also in simplest form. Another example, 3 over 5. Both the numerator 3 and the denominator 5, they're both at the lowest common factor. They couldn't be reduced down anymore. Take, for example, 4 over 16, though. The book might ask you in later chapters to simplify a fraction like this. If we're going to simplify a fraction like this, we have to look at common factors of both 4 and 16. Your first instinct might be 2. Okay, we could take 2 out of 4 and we could take 2 out of 16. If we took 2 out of 4, our new numerator would be 2. 4 divided by 2 is 2. 16 divided by 2 is 8. And you say, oh, I simplified it, 2 over 8. That is true, but when we want to do it in simplest form, we're going to have to look for the largest factor that we could take out of both 4 and 16. Think about what is a factor of both 4 and 16, and what's the largest common factor? Hopefully you said 4. Let's try it. We take 4 out of that numerator 4. 4 divided by 4 is 1. 16 divided by 4 is 4. So this fraction in simplest form would really be 1 over 4. There's another example of simplest form. These fractions are in simplest form. 4 over 16 reduced down to 1 over 4 is now simplified, simplest form. Another thing that the chapter introduction is going to introduce you to are mixed numbers. Mixed numbers are basically when we have a whole number and a fraction side by side. So for example, 1.5. I'm sure you see that all the time. Goodness, where would you see 1.5? Maybe with your eating, let's say, cookies. You might eat 1.5 cookies, right? Or let's say that you're filling up glasses. You might fill up 1.5 glasses. You have 1.5 glass of milk or soda or something. Here's some other examples of mixed numbers: 2 and 5/8, as well as 6 and 9/10. You've got a whole number, and then you've got part of a whole number, a fraction, right? And then lastly, unit fractions. Unit fractions. We've got a upset baby apparently. Unit fractions are basically fractions where the numerator is 1. 1 over 2, 1 over 4, 1 over 5. The numerator in all of those is 1. Unit fractions. Now let's look at what we're going to be doing in 7.1. We're going to be adding fractions and subtracting fractions. Let's look at this first one. Let's say we've got a piece of pie. Blueberry pie is my favorite, but perhaps you want to imagine it as a piece of pumpkin pie or apple pie. We've got half of a pie here, 3 over 6. I've lightly shaded 3 out of 6 parts. So we're looking at this as half a pie, 3 pieces over 6 total pieces. All right. And if we want to add this half-eaten pie with a 1 leftover piece, 1 over 6, well, we can do that very easily, right? We can combine 3/6 with 1/6. If you'll notice on our far right, we have this new fraction of 4/6. Now what you should immediately notice is that 3/6 plus 1/6 is 4/6, not 4/12. Perhaps you would be tempted to add the numerators as well as the denominators. That's simply not necessary. You just add the numerators. The assumption, or kind of the way you're supposed to think about it, is that we're talking about the same whole, 6 parts of the same whole. So you're not combining 2 pies, you're combining parts of pies. So you're combining 3 parts with 1 part to end up with 4 parts. 4 parts over 6 total, or 6 potential parts. 3/6 plus 1/6 equals 4/6. Let's look at it now with a little subtraction. You're going to see different shapes. They do a lot of models in 7.1. In this first example, if you count how many total parts we have, this rhombus, and then, or excuse me, I guess it would be a parallelogram. This parallelogram, you've got 5 total parts. I'll point them out to you. 1, 2, 3, 4, 5. All right. But our fraction, the parts that are colored in, are 3 over 5. 3 out of 5 total parts. Now the symbol, when they model these, the symbol that they use to take away or to subtract a part is basically a circle with an X through it. You see the circle and this X through it. That's just the symbol that they use of taking a part away. So if you've got 3 parts out of 5 total parts, 3/5, and we take away one part, 1 over 5, 3/5 minus 1/5 is, well, you could just count up there, 2/5. 3/5 minus 1/5 is 2/5. And again, you did not have to do really anything to the numerator, or excuse me, you did not have to do anything to the denominator. The denominator stays because we're still talking about out of 5 total parts. So if we took 3 parts away from, if we took 1 part away from 3 parts, you're gonna end up with 2 over 5, 2 out of 5 parts. Let's look at one last one. We have another circle down here. I'm now army crawling on the ground. But let's say we're looking at a circle again. There are 4 parts here. And you can't tell real well, but we've colored in 2 of them. So we've got 2 out of 4, 2 over 4. But then I use this kind of take it away symbol. So 2/4 minus 1/4. Can you do that? Again, you don't have to do anything to denominators, just focus on the numerators. All you have to do is count which one's left. We have that 1 left. 2/4 minus 1/4 equals 1/4. All right, ladies and gentlemen, the book is going to give you plenty of practice at it. Send me pictures, send me questions, and we'll do a fantastic job together. All right, have a good day. Work hard.